Hello guys, this is Prime Concept once again. I will have a problem we want to analyze, and this is a problem under optical invariant. So from what we did in our previous video, I explained optical invariant, mentioning that optical invariant is a mathematical relation that shows the connection between optical parameters when you have a pair or you have two-sided media. Now, we want to consider a problem that will clarify that explanation. So let me draw. Now we have in an air, water, glass parallel-sided media. So we have air, so meaning that light is traveling from air to water and then from water to glass back to air. So that's why we have air, water, glass parallel-sided. So I'll draw that. We have something like this. So this is air, this is water, and then this is glass. So we have our incident angle here. We have our R1, our first refracted angle. Now when this enters here, it becomes incident to this. Remember, this is still R1. Now when it comes, it bends again. This becomes R2, right? When it gets here, it becomes, this is still your R2, so that you then have your emergent angle in this case, right? Now, this is what this question is simply talking about. Now, they said calculate the angles of refraction in water, which is here, water and glass, R1 and R2. So we want to find the refractive index R1 in water and the refractive index R2 in glass. So those are just the two things we want to find. They said if the refractive index in water relative to air is this, that in glass relative to water is this, and then that's in air relative to glass is 1. So they gave us the refractive index. So we can simply call this so that we can avoid ambiguity. We can call this N air, N water, then N glass, and these are just the values they gave us, right? Now something is missing, which I believe I omitted when I was writing the question. What is that? What is missing is that I is equal to 30 degrees. Now let me confirm that. Okay, so that is the angle of incidence. So that is the actual value. I omitted it. I forgot to add it. Is in the question. Now let's solve this problem very quickly. We're trying to find two things. What the question wants us to find is R1 and then R2. So these are the two things we want to find very quickly. So I'll drop this part so I can have space. Now from my diagram, I'm applying the optical invariant relation. What is the relation for optical invariant? You are very correct. Simply says n sine theta, or let's say n1 sine theta 1 equals n2 sine theta 2. So this is the relation for optical invariant. So applying it for this first pair of media, air to water, I'm going to have my first refractive index in this case is NA, right? So it's NA sine, my first angle is sine I, equals my second refractive index is NW. My second angle here is what? R1. So if I substitute these values, NA is 1, which was given, times sine 30 degrees, because NW is 1.33, which was also given, times sine R1. So we're trying to find R1. So I'm going to make that the subject. So I have sine R1 equals 1 times sine 30 degrees divided by 1.33. So that if you punch this, you would have 0.5, which is sine 30 divided by 1.33. So we would have 0.3759, so that R1 becomes sine inverse of 0.3759 59, so which will give us an approximate value of 22 degree. So this is our R1, our first angle. So I'm going to rub because of space so that we can also find R2. So considering the same idea, let me rub from here. Considering the same idea, considering water to glass, I would have N water sine, my angle in this case now is R1, sine R1 equals N glass. My angle in this case is sine what now? R2. So if I consider this case, I would have that N water is 1.33 times sine R1, which is equal to what now? Ng. What is Ng? Ng is 1.5 times sine R2. Now, if you notice this part, 1.33 sine R1, 1.33 sine R1 is equal to what? 1 times sine 30. So I'm going to replace this with 1 times sine 30, so it will be easy. So I would have 1 times sine 30 degree, which is this part now, this, which is this, right? Equals what now? 1.5 sine R2. So if I do this, I would have that sine R2 would give me sine 30 divided by 1.5, right? Yes. So that when I do that, I would obtain sine 30, which is 0.5 divided by 1.5. So I have that sine R2 is going to be 0.3333. I want to find R2, so R2 becomes sine inverse of 0.3333. So when you punch this with your calculator, I want you to put the answer you would get in the comment section, so I would really know that you have watched this video up till the end. I believe that this concept is very clear to you. If you have followed me till this point, please do well to hit the subscribe button if you've not subscribed. If you are already subscribed, do well to like the video, comment and share with your friends so that they can also benefit. Remember, this is Prime Concept. Thank you.